السلام عليكم ورحمة الله. هلا بدنا نبلش بالsecond part of chemical reaction of alcohol, which is the catalytic oxidation. Catalytic oxidation of an alcohol, it is also applied for a primary and secondary alcohol, as we take in a previous video number 1. The catalytic oxidation of the mild oxidation is only applied for a primary and secondary alcohol, where the tertiary alcohol make no reaction. In this reaction, the primary and secondary alcohol take place in the presence of oxygen gas of air. يعني this reaction, the alcohol is mixed with an oxygen gas or mixed with air in order to make an oxidation of alcohol in the presence of oxygen. And the same as catalytic dehydrogenation, we have a copper catalyst. The similarity between catalytic dehydrogenation and catalytic oxidation, they have the same catalyst, the whole copper, with a heat at 300 degrees Celsius. The difference between catalytic oxidation and catalytic dehydrogenation is that in dehydrogenation there is no oxygen gas involved in the reaction. Here there is an oxygen gas. Primary alcohol, when react with oxygen gas, it is changed into aldehyde, similar as in catalytic dehydrogenation. Primary alcohol is changed into aldehyde, and the other product is water, whereas in catalytic dehydrogenation the product is a hydrogen gas. And the same product obtained in catalytic dehydrogenation, it produces an aldehyde, but with addition of water. So primary alcohol is changed into aldehyde. The new product is a water. In the general equation of catalytic oxidation is that primary alcohol plus half O2 for balancing equation. We have plus half O2 plus half O2. As we said, in mild oxidation, the functional group of alcohol is changed into another functional group, into another compound or another group, which is an aldehyde. Aldehyde, as we take previously, it is C double bond O with H in addition to water. And as an example, if I want to write the catalytic oxidation of ethanol will change the functional group or the carbon of the functional group into a carbonyl group with hydrogen, and the part of methyl group will remain the same. So the carbon chain or the alkyl chain methyl group CH3 remains the same. We only change the functional group or carbon of functional group into a carbonyl group. I can write as CO bond H plus the other product is H2O. Also, I can write in this compound aldehyde, I can write as CH3 C double bond O and H plus the other product is the water. So this is the functional group of an aldehyde. This is the functional group of an aldehyde. If I take another example, for example, as a primary alcohol, هو عندي 1 propanol CH3 CH2 CHOH during catalytic oxidation, يعني plus half O2 as a balanced equation, it will give the same carbon chain. This carbon chain or alkyl chain remain constant. We don't change this carbon chain CH3 CH2. We only change the functional group of alcohol. It will change into CO and H plus the other product is H2O. if I take another example, which is, for example, if I have CH3, CH2, CH3, CH, CH3, for example, and CH2OH. Upon catalytic oxidation, we add half O2 to give this carbon chain. Doesn't it change? We don't change any one of these carbon atom. We don't change their number of hydrogen. We'll conserve this part, CH3, CH2, CH, CH3. We only change the carbon of the hydroxyl group into C double bond OH, plus the other product is water. This is a catalytic oxidation of a primary alcohol. In first step, it will change into aldehyde. Okay. In condition if there is an excess of oxygen gas. If we have in this reaction, in catalytic oxidation, we have an excess of oxygen gas. If we have an excess, we must pay attention for this. If the reaction takes place in excess of oxygen gas, the oxidation, the previous reaction that where the primary alcohol is changed into aldehyde, this reaction will continue, and the aldehyde that is obtained in first step will continue reaction with oxygen to produce the final product. To produce a final product is a carboxylic acid. So the net equation, if primary alcohol is mixed with an excess amount of oxygen gas and an excess amount of oxygen gas, it will produces a carboxylic acid. يعني alcohol will change into another organic compound which have a general formula R, COOH, plus in addition to this product is water. This reaction is known as continuous mild oxidation. If an exercise or an example, if we write the equation of a continuous mild oxidation of a certain primary alcohol, I will change into a carboxylic acid. Sometimes instead of continuous, we can use a complete mild oxidation in general. So we only change the functional group of a primary alcohol into another functional group of carboxylic acid. The functional group of carboxylic acid is COOH. Also, carboxylic acid, we can write it as following. This carboxylic group can be written as C double bond O with OH. This part is known as carboxyl group. The coefficient here in this reaction, the oxygen has a coefficient 1, and the 1 oxygen. If it is not a continuous mild oxidation, the coefficient of oxygen is half O2. So if ethanol in an experiment, he said ethanol undergoes a continuous mild oxidation, or ethanol is mixed with an excess of oxygen gas, so I will know that this primary alcohol will change into carboxylic acid. I only change this group of a primary alcohol into, we have CH3COOH will change into COOH plus H2O. So this functional group is changed into a carboxyl group. If I have a continuous mild oxidation, if one propanol mixed with excess, if he mentions there is an excess of oxygen gas, then the reaction will be as following. 1-propanol is written as CH3, CH2, CH2OH. This part of a primary alcohol plus the reaction oxygen gas will change into the carbon chain remains the same. We don't change the carbon chain. So CH3, CH2, we only change the functional group of alcohol into COOH. Then we change the functional group of alcohol into COOH, plus the other product of this reaction is water. This is an continuous mild oxidation of a primary alcohol. So in this case, in catalytic oxidation, the primary alcohol can produces two different organic products. First step, it changes into aldehyde. If we have an excess of oxygen, will change into carboxylic acid. So we can summarize the primary alcohol in catalytic oxidation. If we have primary alcohol, in the presence of oxygen gas O2, it is changed into aldehyde. This is the product obtained. In addition, it to water compound الالdehyde اللي هو as a general form RCOH. If this primary alcohol in the presence of excess of oxygen gas is changed into carboxylic acid, and in addition to formation of water molecule, carboxylic acid is written as RC double bond OOH. Is an primary alcohol. In this type of reaction, we have two possible products according to the condition of the experiment. If the amount of oxygen is sufficient, it produces or change into aldehyde. If it is an excess amount, there is an excess amount of oxygen gas, the reaction will produces carboxylic acid. Whereas secondary alcohol in catalytic oxidation will produces or change into ketone. Only. There is only one possible product for catalytic oxidation of secondary alcohol, different from primary, is an alcohol. A secondary alcohol in presence of oxygen, if there is insufficient amount of oxygen, or even an excess amount of oxygen, whatever the quantity of oxygen gas, the secondary alcohol always changed into ketone with a coefficient which does not change. The coefficient of oxygen here is half O2, and also the other product obtained is water molecule. Here is an example. Write using the condensed structural formula the equations of the following reaction. We have 2-propanol with an oxygen. If I want to write the equation of this reaction, I will 2-propanol with an oxygen. So 2-propanol, the condensed structural formula of 2-propanol, we have propanol CH3, CH is on the position number 2, we have OH group had a position number 2, 2-propanol plus CH3. Then we have a secondary alcohol. Secondary alcohol, when react with oxygen, I write half O2. The product obtained is that we only change this functional group into a carbonyl group. A ketone is characterized by a carbonyl group. So the carbonyl chain is CH3. I only change it into carbonyl group CO. The other carbon remain constant. The other product is water. So the secondary alcohol is changed into hydroxyl group of secondary alcohol, the carbon changed into carbonyl group. This is the reaction of 2-propanol with an oxygen gas. So the equation is written as CH3CHOH plus half O2. This is the product of the reaction. Another example is as we see here, he gave as a condition of a continuous mild oxidation. He mentions that there is a continuous mild oxidation of a 3-methyl-1-butanol. Is an 1-butanol position of hydroxyl group on number 1, so it is a primary alcohol. Isn't in order to write the equation of oxidation, continuous oxidation of a primary alcohol, this means this primary alcohol will change into carboxylic acid. Okay, to write the equation of the reaction, we have a butanol is 1, 2, 3, 4. 1 butanol, we have CH2OH is the first carbon. On number 3, we have a methyl group, CH3. We complete the hydrogen atom for the other carbon. Plus, since there is mentioned a continuous mild oxidation, I write the O2. The coefficient of oxygen is 1. The product is the primary alcohol will change into carboxylic acid. So I'll conserve the carbon chain. I'll conserve this carbon chain. I conserve it without it changing in the shape of the carbon or the shape of the branch chain. We conserve the shape of the carbon chain, and with the of its hydrogen atom, we write it the same: CH3, CH3, CH2. We conserve the carbon chain with its hydrogen. We only change the functional group of a primary into carboxylic acid. Carboxylic acid يعني it will have a functional group اللي هو COOH. It will contain the following functional group: COOH, the carboxyl group, plus the other product of this reaction is water. So we change it into a carboxylic acid. So the equation of the reaction is written as following: CH3, CH3, and as we see that the functional group of a primary alcohol CHOH, CH2OH is changed into COOH. Then we will continue with this example. We have a catalytic dehydrogenation. Here we have a revision for the catalytic dehydrogenation of 2-butanol. 2-butanol, if I want to write the equation of this reaction, the condensed structural form of 2-butanol, and we have 4 carbon atom. On the second carbon we have OH group, so we fill the hydrogen for each carbon, CH2H, CH3. So it is a secondary alcohol. Secondary alcohol, when it undergoes catalytic dehydrogenation, directly we change into a ketone. It will change into ketone group. Secondary alcohol change in ketone. We only change this carbon of the hydroxyl group into a carbonyl group, C double bond O, and we write the remaining part CH3, CH2 on the left side, and we have CH3 on the other side. The other product, since it is a dehydrogenation, and it will produces a hydrogen gas. This is the equation of the reaction. For catalytic oxidation, we have catalytic oxidation of one propanol. إذا one position number one we have يعني a primary alcohol. We have a primary alcohol. إذا we have position number one, we have primary alcohol, we have catalytic oxidation. In this example here, I don't mention if there is an oxygen gas or not. Since there is no mention for excess of oxygen gas, this means primary alcohol will change into aldehyde. Since there is no mention, we don't mention the word excess in the presence of excess of oxygen gas, so this means this primary alcohol will change into aldehyde. Then we write the condensed structural formula of 2,2-dimethyl 1-propanol. فإذا 1 2 3 هذا البرايمري alcohol. عندي على position number 2 we have dimethyl group CH3 CH3, this is CH3. Since we have a catalytic oxidation plus half O2, since there is no excess of oxygen gas, I don't mention the word excess, so we have half O2. Then the product is 1-propanol. When our primary alcohol when undergoes oxidation in absence of oxygen gas, مش in absence, if the amount of oxygen gas are sufficient enough, it will change into aldehyde. We change into aldehyde. يعني this part this will change into aldehyde. Aldehyde is characterized by RC, the functional group RC double bond OH, and I replaces the part of the primary alcohol CH2OH into C double bond OH. So I conserve the carbon chain as it CH3, C CH3, CH3, and IT change into aldehyde group C double bond OH. The other product in catalytic oxidation is CH2 is H2O water product. So this is the equation of the reaction. This is a part of catalytic oxidation for primary and secondary alcohol.